Okay, if you guys can turn to page 4.
Basketball wasn't all about points. Like Coach James said.
Yeah, who's looking at that?
Well, you just retarded.
Okay, if you guys can copy down this definition here, vector. Okay, so vector is a quantity that has both direction and magnitude. Okay, so we're going to see these arrows that represent vectors. It's going to indicate magnitude in the sense that it tells us how much or how large that quantity is. But then it also has direction as well. Yes.
I wasn't here Friday.
Okay, yeah, packet. And then we're going to see different variations of direction and magnitude, but just a quick example would be like velocity, okay, versus speed. Right, speed is only magnitude, tells you how fast you're going, but then velocity actually has a direction and quantity to it. Okay, so it says use the following to draw each vector diagram and resultant vector. That's going to be the basically the combined vectors. Find the magnitude of the resultants. Okay, we'll come back and deal with the we'll come back and we'll deal with the magnitude. Let's just go ahead and learn how to draw these vectors here. So here we have vector B. You see vector B kind of has this direction and also has this distance about it. So we're going to create, we're going to take this vector B and we're going to make it have the same direction, but we're going to make it twice as long. So we see that this vector B is starting at this point, is going to go up to and over 1, 2, 1, 2, 3, 4, 5, 6, right? Up to over 6. That's the length or the direction of our vector. So let's start at the very bottom corner here. Okay, and we'll go up to and over 6. So we know that this is going to be the length of one vector B, but we want 2 of vector B. So we'll go through that process again. We'll go up to and over 6 as well. So if I connect those 3 dots, I will have the length of vector 2B. Okay, number 2, we want to take vector A. We want it to be -3, so not only are we going to make it 3 times as long, we're going to make it change direction. So instead of going from left to right, 3 units, we're going to make it go from right to left, and we're going to triple that distance. So let me start at the very right. Doesn't matter where you start on the right, it can be higher or lower. It's just going to be a straight line across. 1, 2, 3. 1, 2, 3. Okay, any questions here? Okay, number 3, 2a plus c. So what we're going to do is we're going to take vector a, double it, and then wherever it ends, we're going to basically take a vector c and attach it to the end of vector 2a. So we're going to do 2 of these followed by this. Okay, and because the graph is going to go down, I'm going to start as high as I can because I know I'm going to have to go make my way down. So I'm going to start at the very top here. We know vector A is going to span across 3 units. So let me start at near the top. So 3 units. So 1, 2, 3. That's vector A. 1, 2, 3. Vector 2A. And now I want to implement vector C at the end of vector 2A. And then C, we have 1, 2, 3, 4. So 4 units up to the right, 6 units down. So 4 units to the right, 6 units down. Okay, so basically I'm just going to take this diagram and tack it on to the end of vector 2A. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So it says the resultant vector. So if I were to add these 2 vectors together, what's gonna basically come out of this is something that starts here and ends here. So basically, I just have to create a vector that starts at the starting point and ends at the ending point of these 2 sums. So I'll start here at my starting point, and I have to end here. And I'll use different color here. Okay, so that's my resultant vector. This is what the result of 2a plus c would be. I just want to show you that there's a different method, meaning that I can also get the same resultant vector. I don't have to do it in this order. I can do vector c first, then I add on 2a, and then create my final vector, and I'm still going to get the same shape, the same distance, and also the same direction. Okay, so let's try it. Let's say we did vector c first. Okay, so let's say you want to do c plus 2a. We should get the same result. Okay. Again, I'll start at the same location, but instead of doing 2a, I'm going to do vector c first. So vector c is over 4 down 6. vector notation has this arrow above the letter with just this upper part of the arrow. Okay, we have to do 2A as well. We know 2A is going to be 6 units to the right. Okay, resultant vector starts at our initial point and ends terminal point there. So we end up with the same resultant vector. If I were to take this and overlap it, I'm going to get the same length and also the same direction. All right, or C plus 2A, same thing. Okay, this is vector B followed by -1/2 C. So let's do vector B first. Vector B, we're going to have to make it go up 2 and over 6. I'll start at the bottom corner here. Okay, up 2 over 6. But it's -1/2 C. So not only are we going to make C half the distance, we're also going to make it go which direction? It's going to go up, right? It's going to go up towards, up and to the left. So instead of going down 3 over 2, we're going to make it go up 3 over 2. Right? So C was 4 and 6. Now we're going to make it 2 and 3, or in this case, 3 and 2. So there's my B, there's my -1/2 C. To find my resultant vector, I just start where where this process started and end where it ends. Okay, let's go back and talk about finding the magnitude. So magnitude is basically finding if we see a diagonal line, we're just going to make it into a Pythagorean theorem problem. Imagine you're finding the hypotenuse of a triangle. Okay, so let's go back and do magnitude here. Now, if it's just a horizontal line, we can just count that distance, right? So here the magnitude is just going to be 1, 2, 3. Let's see, notation. So I'll say magnitude of vector A is equal to 3. So it looks like absolute value bar, but that just indicates that we're talking about the magnitude. Here, vector B, we go up 2 over 6. Imagine you're just finding the length of the hypotenuse. A squared plus B squared equals C squared, and we just take the square root of that. So up 2 over 6. Okay, vector C. It doesn't matter which way you go. You can just create a right triangle and just find the hypotenuse of that length. Square root of 52. Okay, vector 2b. So it's going to be up 4 over 12. This one you can just count, right? This is going to be just 9 units. And it's always going to be positive. So magnitude, we don't care about the direction. We're just going to find the positive version of it. Okay, we want to find the magnitude of this resultant vector. So let's just create a right triangle out of this vector. We don't want to use this original one. This is not a right triangle. So we can just count down and count to the right, and then go a squared plus b squared equals c squared, right? Okay. These are the same thing, so we're 136 in both of these. Okay. For number 4, force this to be the hypotenuse of a right triangle. 1, 2, 3, 4, 5. Okay, questions there? Okay, now below here it says state whether each quantity described is a vector quantity or a scalar quantity. So I want to kind of differentiate between these two here. So a vector quantity has both direction and magnitude. But a scalar quantity only has magnitude. Okay, so state whether each quantity described as vector quantity or scalar quantity, a box being pushed with a force of 125 newtons. What do you guys think? Scalar, right? We know what the force is, but we have no idea which direction it's being moved. Wind is blowing 20 knots. Scalar, we don't know which direction it's headed. A deer running 15 meters per second due west. Vector, right? We have direction involved here. 15-pound tire hanging from a rope. It's also vector. 15-pound tire, it's hanging down. It's being, force of gravity is pushing it down, right? So there's a direction there. Okay, so your classwork is just 1 through 6. You're going to draw and label the resultant vector, find the magnitude, just like how we did the first page. Okay. I'll work the problem as you guys are doing it, and then we'll check our answers, and it'll be a short day today. Okay, does anybody still need this page? Okay, any questions?